All right, today we're going to be looking at section 4.5 optimization problems. In the beginning, they give you many different instances where this could be used. It just says a structural engineer may want to seek dimensions of a beam that will maximize the strength for a specific cost. Packaging designer may seek dimensions of a container that maximize the volume of the container for a given surface area. Airline strategists need to find the best allocation of airliners among several hubs to minimize fuel costs and maximize passenger miles. So different things where we want to maximize or minimize something. We'll be dealing with usually two functions. One will be a constraint. So they're giving us an example of we want to find two numbers that add up to be 20 but have the greatest product. So there's a lot of different numbers that add to be 20 or pairs, and you can kind of see some in the table. That constraint is the x plus y equals 20. Then you'll have an objective function, which is trying to maximize or minimize something. So that's the product in this case. P is x times y, so that it is the largest product possible. It goes through the solving process. You'll solve the constraint for a specified variable, plug it into the objective function, and then compute a derivative and find that maximum or minimum. Here you also get to see some other examples. Rancher's dilemma, where he's trying to build a barn to certain specifications that's going to maximize the area. You have one with the airline regulations again, talking about baggage dimensions. So after you see several, we get some guidelines for solving optimization. And again, these are just to help you along the process, not a one-size-fits-all, step-by-step that's going to work every single time, but it should get you in the general direction. But it just says read the problem carefully, identify the variables. You're going to identify the objective function, the one to be optimized. You're going to identify the constraints. You'll use those constraints to eliminate all but one variable for the objective function. And then with the objective function expressed in a single variable, we will find the interval of interest, and then we'll use those methods to find the absolute maximum or minimum of the objective function. If necessary, we check the endpoints. So then you got to get a few more examples of different applications of optimization. You got walking and swimming problem. All of these are really good reads using trig, using all the different tools we've used. Ladder over a fence, which is a problem that we will see in the text. And then we have a water tower problem as well, using unit circle and some angles regarding that. So this pretty much gives you like a general overview. These all problems are really good to kind of go over, see what they're doing, make sure you can follow it as additional practice to what we're going to do in my math lab. So with that, we're going to jump over and start solving some problems.